Hello everyone, in today's video we're going to be discussing polynomials. This video is meant to serve as an introduction, and without much further ado, let's go straight into our lesson. So starting off, you're probably wondering what are polynomials, and to simply put it, polynomials are the mathematical expressions that contain multiple terms. Poly means many and nominal means terms, hence its name. So now you're probably still wondering what are many terms, and this leads me into the next topic, the anatomy of a polynomial. So as you see here, I have 3x to the power of 2 plus 4x minus 5. The first three numbers you see are all grouping of terms. Terms are often separated by addition or subtraction signs. That's how you can identify a term. Now let's look a little deeper into a term. A term can have an exponent just like our first term, 3x to the power of 2. But unlike that term, on the very far right, we have a term of just a 5. A term can also be alone and stand by itself. It's still a term. We call this a constant. A constant tends to be a term without an exponent or variable. Now this makes us go into variables. The variables are those x's you see in the expression or in separate terms. In other words, letters you see in a mathematical expression or equation. And you tend to learn this in pre-algebra or algebra 1. So, in front of those variables are coefficients, which in this case would be 3 and 4. All right, so the coefficients will go in front of that variable and exponent. So now that you know the anatomy of excuse me. So now that you know the anatomy of a polynomial, it's very important that you know how to write a polynomial. So this leads us into standard form. Standard form is when you start with the biggest exponent value you have and then decrease along the way. So you start with the biggest to smallest exponent you have. So in our example, I have 5x to the power of 4x plus 3x to the power of 3 plus 2x to the power of 2 minus 8. If you notice that each exponent decreases in the following order, 4, 3, 2, right? These are all in numerical value. So when you put your polynomial in this order, it creates the standard form, which is very important to solve, and you must have your polynomial in standard form. So now you're probably wondering, what does standard form have to do with anything? And this actually coincides with the leading term and leading coefficient. But we're going to start with the leading term. So a leading term is when our term has the highest degree, which we will circle back to later on in the video. The highest degree is the largest exponent that you will have in your polynomial expression. So now I have in my example 4x to the power of 4 plus 3x to the power of 3 plus 2x to the power of 2 minus 8, right? And as you see here, 5x to the power of 4 would be my leading term because it has the biggest exponent here. Hence why we went over standard form. So 5x to the power of 4 is the leading term because the exponent here is the biggest. And the leading term will be at the very front of your polynomial expression. So this leads us into the leading coefficient. And they are both very similar, just two different parts of a polynomial. So the leading coefficient is usually the biggest number, and this leading coefficient goes hand in hand with the leading term because they are both at the very beginning of your expression. So for example, I have 5x to the power of 4 plus 3x to the power of 3 plus 2x to the power of 2 minus 8, right? And 5x to the power of 4 would be my leading coefficient because 5 is the biggest number here. 3 and 2 are the smallest number here, but I still put them in numerical value. And when you have that bigger coefficient, that is your leading coefficient. That's essentially what leading coefficient is. So now this leads us into how polynomials are classified. And polynomials could be classified in two different ways, by degree and by terms. And we did mention degree a little, maybe 20 seconds ago. So we're going to start with terms because those tend to be the easiest. So I have four different ways I can classify a polynomial by the term. So I have mononomial, I have binomial, and I have trinominal, and I have polynomial. Mononomial stands for one term, binomial stands for two terms, trinominal stands for three terms, and polynomial stands for four terms or more. So starting off with the mononomial, I can have 8x to the power of 2, I can have 7, I can have negative 4x to the power of 2, and these will all be mononomials. these are all one term. And as you see, they do not have an addition or subtraction sign. So these are all one term. Now, if I want to go a step further, I can have binomial, which would be two terms. And this could look like 5 plus 4x, 8y to the power of 2 minus 2, or negative 4n2 plus 2. These are all two terms, and as you see that these groupings of numbers are separated by a operation sign, which would be addition or subtraction. So this leads me to trinominal, three terms. So I can have x plus 7x minus 4, 3m to the power of 2 minus 5, or I can even have 6y to the power of 2 plus 4 plus 1. These are all trinomials. These are all three terms. And as you see, all three groupings of numbers, in other words, terms, are separated by the addition and subtraction sign. So really paying attention to that operation sign and seeing where a new number starts is basically going to tell you how many terms you have. Now, if I want to go to polynomials, I know this would be four terms or more. So I have x1, x to the power of 1, plus 7x to the power of 2, minus 3, minus 1. This is four terms, and this makes it polynomial. I would classify this as a polynomial. Or I could have x plus 7x minus 3 plus 1x plus 4. This is five terms, and I know it's a polynomial because a polynomial must be four terms or more. I can even have 9x plus 1 plus 2x minus 5 plus 2x, and this would be six terms, and it's still a polynomial because a polynomial has to be what? Four terms or more. So these are the types of polynomials by terms. Now, now I'm going to move on to polynomials by the degree. When you're classifying the degree, this essentially means the highest exponent, which we went over a little bit at the beginning of the video. So, if you know the highest exponent, like it could be 1, 2, 3, 4, 5, and so on and so on, they all have a separate name, which we're going to get to in a little bit. So, starting off, we have a constant, which is degree 0. Then we have a linear, which is degree 1. Then we have a quadric, which is degree 2, and then we have a cubic, which is degree 3, and then we have quadric degree 4, and then we have quantic degree 5. And this can go on and on a little bit longer until you get to the nth power, but we're going to discuss that in another video because this is just an introduction, and I want you guys to have a raw idea of this concept. Okay, we're going to get deeper and deeper into each video we go, because polynomials I feel like are a week worth left of lessons because it goes really, really, really deep. Where this is only the top of the iceberg. Anyways, so now we're gonna start with our constant, and the constant is basically when you have a term, right? You have a term, and they usually stand alone. They do not have a variable and they do not have a power. So we think of these as constants, and these constants are degree zeros. So for example, I have -2, 8, and 1.5. And as we looked at the anatomy of a polynomial, those constants were always alone. And this is what makes it degree 0. Now, if I wanted to have a degree of 1, I would call this a linear, right? And linears are because that variable stands by itself. It doesn't have an exponent at the top. So we call this degree 1. And this could look like -5x plus 9, x plus 3 plus 2. And as you see, those x's stand alone. There is no exponents standing with them. So this is a linear and this is a degree 1. Linear equals degree 1. So now we're going to go on to quadric. And quadric simply stands for the exponent having a 2 at the top. This makes it degree 2. And I guess you could say like exponent 2 is degree 2 because the exponent tells you what degree it is. It's simply that. And this can look like 3x minus 2 minus 2x. And that 3x having that 2 on top and being the leading term and leading coefficient, like we learned a little bit earlier, this makes it degree 2 because that exponent is 2 and we call degree 2 quadric. But most of the time you just call it degree 2. It's more simpler. Anyway, we're going to go on to cubic. Cubic is characterized by its exponent having 3 at the top. This makes it degree 3. Okay, and this can look like 4x minus 2 minus 2x, and that 4x to the power of 3 has that 3, and this makes it degree 3. In other words, cubic. Now we're going to go on to quadric. quadric is characterized by its exponent having 4 at the top. This makes it degree 4, okay? So I can have 5x minus 2 minus 2x, and that 4 in front of that first term and leading term, 5x to the power of 4, is what makes it degree 4. It makes it quadric. And as you see here, you can see the repetition and the pattern going on here, okay? But then this eventually stops at the nth power, which is degree 11, I believe. But we'll discuss that in another video. Going on to quintic. Quintic is characterized by its exponent having 5 at the top. This makes it degree 5. Now 6x minus 2 minus 2x, I have this, but you have that leading term that has a 6x to the power of 5, and this makes it quintic. It's degree 5. That exponent is 5, okay? Now this is where we conclude our video, and if you want to know more about polynomials, then check out some more videos I have. And this is Ari, the math tutor, signing off. See you guys in the next one. Bye!